In today's video, we're going to talk about acceleration in one dimension. Motion along a straight line is called one-dimensional motion. So a person walking down a hallway is one-dimensional motion. This ant on my laptop is not one-dimensional motion because the ant goes in zigzag ways all over my laptop. But what is another example of one-dimensional motion? Rolling a bowling ball down a bowling alley. Can you think of your own example? Of one-dimensional horizontal motion. We can also think of the vertical dimension, like a rising elevator, or a container lifted by a crane, or a falling acorn. What could be your own example of one-dimensional vertical motion, such as raindrop falling from the sky? We see in these two pictures a ball that's rolling. One image, the ball is falling. And in another image, the ball is rolling off of the table. The ball's motion was photographed at equal time intervals. This is important when we analyze the time intervals. Compare the ball's motion in both images. What's different? You might talk about this. What's the space between the balls after every time interval? Does it seem to be changing as it's rolling across? And the ball that's dropping, how is that? How are the spaces between the balls different in these images? Changes in velocity. For an object in motion, the object's position is always changing, and its velocity can also change. Acceleration is a change in velocity. Like displacement and velocity, acceleration is a vector quantity because it has magnitude and direction. Just as velocity is the rate of displacement, we would say delta x divided by delta t. We use this triangle in science equations to just say that something changed. There was a change there. And when I read that equation, I say the word delta to mean a triangle. So velocity is the rate of displacement. It's moving across the x-axis, the horizontal axis, at this rate of speed. Acceleration is the rate of change of velocity. So the velocity changed at a rate of delta t. And velocity can refer to direction or magnitude. It doesn't have to be speeding up or slowing down to accelerate. It can just be turning, such as the way the planet Earth turns as it rotates around the sun. Today we're going to think of patterns in motion. Motion is all around us. We can observe them in many everyday actions. Through our experiences, we form an idea of what patterns of motion are normal and what motion is out of the ordinary and requires further study. My favorite videos are the TikTok guys that are floating when they do those jump steps. It makes it seem out of the ordinary the way they move, but we can figure out that they're tricking us because they're moving in an unordinary way with the way they place their feet. It's pretty smooth. I'll try it for you sometime, but it won't be good. It won't be smooth. When you watch soccer, your experience tells you where to look when the ball is kicked. The goalie especially has to look at the ball. It's coming at me this way, and the goalie has to jump this direction to deflect the ball. So we know from experience that I can use a predictable pattern. What patterns do you see in the motion of the falling billiard ball in the earlier image? What patterns do you see in this image of the one that's falling, of this one? When we analyze horizontal motion, think about changes. Suppose the ball is rolling right to the right at a constant velocity. So we can see the spaces here between each time interval are the same magnitude. There's the same distance between the ball. As the ball hits a spring, it slows down. So now we see less magnitude between the ball as it hits the spring, and the spring compresses. It comes to rest and then accelerates to the left as the spring expands. And then it resumes a constant velocity that direction. So I would like you to analyze the horizontal motion of this ball. Describe the acceleration of the ball before, during, and after hitting the spring. When we describe acceleration, describe how the velocity changes. Before, think of these 3 time intervals. During, think of these 3 time intervals. And after, think of these 3. And then say, how does the spring affect the velocity and acceleration? The velocity, recall, is the change, is the change along the x-axis in this example, since it's horizontal motion, over time. How is that changing? How is acceleration includes And velocity also includes direction as well. So we see this graph showing the position away from the zero as the starting point, and it returns to zero. So we could say, describe this motion and say, how did the spring affect that?